ये आवाज आ गई।
Good evening, Dr. Yadav sir. अच्छा धर्मेंद्र हैं.
Okay. So
Very good evening. Very good evening.
good evening, sir, and good evening, Dr. Singh.
Yes, yes. Good evening, Dr. Dharmendra.
So I think we can wait 5 minutes because participants are joining.
Definitely.
We can wait. There are 32 participants
32,
right now,
yeah.
so we can wait 5 minutes, sir.
Okay.
यहीं से चलता है सर।
अच्छा अच्छा अच्छा। तो तुमने कहा आधा घंटा लगेगा, तो मैंने कहा यार आधा घंटा या पौन घंटा तुम्हें लग सकता है।
So, Dr. Singh, can we start?
Yes, 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 yes. We start.
So, just
Recording in progress.
so very good evening to all the participants and welcome to this 4th day of 1 week online faculty development program on advanced research methodology. Myself, Dr. Dilshad, welcome to all of you. So, it's really a great privilege for us that our esteemed resource person, Dr. S.K. Yadav, has joined for today's session. So, Dr. S.K. Yadav is a eminent research experience in the field of statistics and applied areas. And he is a well-known academician, and he is published more than 100 research papers in the field of statistics and related areas. He is a awardee of various national international awards, and he has presented and delivered many invited talks in the national international conferences. So welcome you, sir, and thanks for being the resource person for this today's session.
Thank you, Dr. Yadav.
So it's really a great privilege for all of us to get benefit from your teaching and research experience. And please, you can share the screen now. It's over to you, sir.
Thank you. Okay, a very good evening to all of you. And first of all, I would like to thank to the organizer, Dr. Singh, Dr. Yadav, Professor Shukla, and principal of the college for giving me opportunity to express my view regarding the assigned topic. So without delay, I think we should start. So let me share the screen and then we'll be discussing the things. Is it visible?
Yes, sir.
Now I think it is on PPT mode.
Yes.
So today we'll be discussing data collection as well as its visualization. So first of all, I would like to mention here that statistics is a tool that converts the data into information. So as you can see here in the picture, the data itself is saying nothing, and when you apply the statistical tools, then you get the appropriate information. Now there are so many questions which are written here, that now the question is, where does data come from, how it is gathered, how do we ensure its accuracy, is the data reliable, is it representative of the population from which it was drawn, and how to prepare it for the analysis. So one by one the things will be discussed here. Now first of all, we will be discussing what is data. So it is data, the collection of things or unstructured say information, and when we use the statistics, we get the information. So sometimes we call it the data as the collection of information. So the collection, organization and presentation of data are basic background material for learning descriptive and inferential statistics. So there are two basic parts of statistics. One is descriptive statistics and another one is inferential statistics, or the inference, and their applications obviously. So method for we will be discussing different methods of collecting the data and their visualization, or how we will be presenting in different graphs, in terms of different graphs, how to visualize that data in terms of say graphs and tables. So on the basis of the source of collection, data may be classified as, so before discussing the methods of collection of the data, we will be discussing different types of data. So first we will discuss about different types of data, and then the methods of collecting the data, and then the presentation of this data in terms of different graphs and tables, and that is visualization of the data. So we know the data is of two types: primary data as well as secondary data. The primary data is the data which is collected at first hand or first time, and to analyze the things, to get the information regarding the characteristic under investigation. And the data which has been collected earlier and used for some purpose, and if we are using it for some another purpose, then this is known as secondary data. We will be discussing further in next slide. And these primary as well as secondary data, both type of data, are of two types. Both may be numerical data and categorical data. So there are two types of data. The numerical data means the data which may be presented in terms of numbers, that is in terms of quantity. Sometimes we call it as quantitative data as well. And the another one is categorical data, that is which is represented in terms of attributes, which is not represented in terms of say quantity. It is not quantitative. That is why sometimes we call it as qualitative data. So these are types of the data, primary and secondary data. So primary data means data collected by the investigator himself or herself for a specific purpose is known as primary data. For example, data collected by a student for her or his thesis or research project is the first hand data. Or you can say, if you are doing a project and you are collecting the data, or you are doing some experiment and you are getting data first time, then this will be the primary data. Now secondary data, data collected by someone else for some other purpose, but being utilized by the investigator for some other purpose. So this type of data is known as secondary data. And examples of secondary data is census data, being used to analyze the impact of education on career choice and earning, and many other purposes. So you can many people are using this census data for different purposes. So this is the secondary data, because the government is providing this data, and government has collected this data, or the agency has collected the data for some purpose, and the people are using it for some other purposes. So that is why it is secondary data. Now these two data, primary as well as secondary, both may be of qualitative and quantitative types. As we have discussed earlier, quantitative means if the data is represented in terms of say numbers, in terms of quantity, so this is known as qualitative data. And if it cannot be quantified, then we represent it in terms of different categories, say. So because attributes may not be represented in terms of quantity, so sometimes we call them as attribute as well as qualitative data. Now there are four measures of this, I mean scale of measurement for measuring these data, primary as well as secondary, and quantitative as well as qualitative or categorical, because we divide it into different categories. That is why sometimes qualitative data is also known as categorical data. So there are four scale of measurement: nominal, ordinal, interval, and ratio. So the first two belongs to the qualitative data. That is, these are the measurement for measuring the qualitative data or categorical data. And the second two, that is third one and fourth one, interval and ratio scales, are the measures for measuring the quantitative data, or say scale data. So sometimes we call it as scale as well. So sometimes nominal and ordinal data are known as categorical or ordered discrete data, while interval and ratio are known as scale or continuous data. So height and weight, these are the examples of, continuous data, and so these type of data will be measured in either ratio or interval. We will be discussing one by one what is the difference between nominal and ordinal, what is the difference between interval and ratio, and attributes, say honesty, color, and other things. These are measured in terms of qualitative data or categorical data, and these may be of two types, nominal as well as ordinal. So okay, so let us talk about nominal data. If the categorical data, if we have categorized, if we have partitioned the data, qualitative data, in different categories, and if we are not giving any preference to any category, if that is, if we are not applying the ranks to the different categories, then such type of data or measurement is known as nominal scale of measurement. Say gender, male and female, if you are not giving any preference to any gender, then it is on nominal scale. And the ordinal data, yeah, categorical data is known as ordinal when we apply ranks to different categories. So there are three types of, say, teaching jobs in university, that is professor, associate professor, and assistant professor. So they differ in terms of responsibilities, in terms of salaries. So we can apply rank here, that professor is first and associate is second and the third one is assistant professor. Similarly, we can apply in different jobs, in terms of salary, in banking sector, managerial, clerical, custodial. These categories differ in terms of the variable under consideration, that is salary. So here we can apply the ranks. That is why it is known as ordinal data. If ranks are if rank matters, then it is categorical. Otherwise, nominal, ordinal, both are categorical. We categorize the data, qualitative data. But if we are given ranks to the different categories, it is ordinal, because order matters there. That is why it is known as ordinal. So if you are applying the ranks, then it is ordinal. And if you are not applying the ranks, you are, suppose you are giving equal weightage to every category, so it is nominal. Now every quantitative data is represented in term in the scale of ratio, any quantity, continuous data. But there is a minute difference between interval and ratio scale of measurement of the continuous or quantitative data. The only difference between the two is that if 0 is having its absolute meaning, absolute value, say here, I have mentioned here 0 is meaningful. It means if 0 means 0, then it is ratio scale, otherwise interval scale. The example of ratio scale, height, weight, marks, these are the examples of ratio scale. But if 0 is not having its absolute meaning or absolute value, then the scale of measurement is known as interval scale. The examples are temperature, IQ, and many more examples are of interval scale. Because in temperature, 0 temperature doesn't mean there is no temperature. 0 IQ doesn't mean that the person is brainless. He or she know nothing. Maybe in that field he or she is not knowing things. But the IQ, if IQ is 0, it doesn't mean that the person is not having brain. So similarly, the case is of temperature. 0 temperature doesn't mean there is no temperature. So these are the, this is the basic difference between ratio and interval scale of measurement. So these are different examples: ratio scale, height, age, weekly food spending, And interval scale, you can say temperature in Fahrenheit, and standardized exam score. So standardized means it may not be zero. Ordinal scale, if we apply the order to different categories, ranking order or scaling, say here, serving quality rating. So point scale or Likert scale we'll be discussing. These are the ordinal scale of measurement. And rating, obviously rating. So standard, poor, bond rating, student letter grades, and so on. These are different examples of ordinal data. And no ordering or direction in the category if, then it is nominal data. So material status, type of car owned, and if these are different examples of nominal data. Now collection of data. Now we come to the first, we have known about the types of data and different measures of scale of measurement of the data. Now we come to the point of collection of data. So collection of data, the data which are originally collected for the first time, as we have discussed earlier, this is known as primary data. For the purpose of survey are called primary data. For example, facts are data collected regarding the habit of taking tea or coffee in a village by an investigator, and many more examples maybe of the primary data. Now, method of collecting primary data. There are several methods for collecting primary data. Some of them are direct personal investigation, indirect investigations, that is observations. Indirect investigation means observations. Through correspondence, and the correspondence may be mailed questionnaires, and through schedule, and through email or through mail. These may be correspondence. So these are the, one by one we will be discussing different main methods of collection of the data. So there are many methods used to collect or obtain data for statistical analysis. Three of the most popular methods are given as below. The first one is direct observation. Direct observation, also known as observational study, is a method of collecting evaluative information in which the evaluator watches the subject in his or her usual environment without altering the environment. It means we are only observing the things. Direct observation is used when other data collection procedures such as survey, questionnaires, etc. are not effective. It means if the sometimes maybe very sensitive issues, say if you are observing, some uh, like people, like some suspicious peoples, then we don't disturb it, we only observe. So intelligence reports, intelligence persons do this thing, direct observation. So direct observation is used when other data collection procedures such as survey, questionnaire, etc. are not effective, when the goal is to evaluate an ongoing behavior process. Sometimes psychologists also use this direct method, direct observation, to know the behavior of the patient, event or situation, or when there are physical outcomes that can be readily seen. So we are not in situation to see the physical outcomes, so we have to observe the things and then we'll relate the things. And the next one is experiment. We know these are more effective in establishing cause and effect relationship. So in the previous one, it is very hard to, establish the cause and effect relationship. But in experiment, we do this thing. So in an experiment, data collection is done in such a manner as to permit relatively more unambiguous interpretation. So in previous one, it was ambiguous. It may be ambiguous interpretations of the things. Different experts may interpret different things. But in experiment, if it establishes the cause and effect relationship, and every researcher establishes the same thing almost for the same experiment. In the fields of sciences, experiments determine and prove cause and effect relations. These are also being used in marketing research efforts and many more areas of applications in scientific as well as other areas. And the third one, the important one, is the surveys, very well known for the social scientists as well. So a survey collect information from people, that is Gallup polls, pre-election polls, say opinion polls, marketing surveys, the response rate, that is the proportion of all people selected who complete the survey, that is response rate, and the persons who which are not responding, that comes into the category of non-response. So we observe some percentage of non-response in survey. We definitely observe this thing. So is a key survey parameter. So surveys may be administered in a variety of ways. That is, maybe personal interview, maybe telephonic interview, maybe self-administered questionnaire, maybe emailed questionnaire. Now we'll talk about the questionnaire design, because a lot of people has worked on it, and the people are researchers are working on it, how to make the effective and more informative questionnaire. So over the years, a lot of thoughts have been put into the science of designing or making the survey questions. The key design principles are, these are some key points while making the questionnaire design. First one is, keep the questionnaires as short as possible, because people are not having very much time. So nowadays time is very crucial. So people will say that no, I am not having time. So you have to make the questions, even questionnaire should be very short, so that it should it should fulfill your purpose, and questions should also be small. So ask short, simple, and clearly worded questions. Don't ask fuzzy or ambiguous questions. Start with demographic questions to help respondent get started comfortably. Obviously, we should start, say, what is your name? What is your father's name? From where you are? How many brothers you are? How many sisters you are? And so this way, you start asking the questions to make the uh, person comfortable. Use dichotomous, means having only two options, or multiple choice questions. Use open-ended questions cautiously. You don't say, don't leave on the, person. Rarely you should use. You should avoid this. Asking open-ended question. Otherwise, the person will answer hypothetical answer. And avoid using leading questions. Don't ask leading question. Just tell me who is going to win, who is going to win. If the person is going to, the particular person is going to win or not. So this way, this question is actually biased, and this is the bias is towards the surveyor. Surveyor is wishing to get the answer what actually the surveyor want. So we have to avoid using leading questions. So pre-test a questionnaire, definitely it is one of the most crucial part of the survey. So pre-test a questionnaire on a small number of people, which is known as pilot survey, and think about the way you intend to use the collected data. This is very much important. Think about the way you intend to use the collected data when preparing the questionnaire. How you are going to use the data, think about that, then keeping in mind the thing, and that thing, you make the questions or you make the question. So this is a structure of, primary research methods and techniques. You can see here, this is quantitative data and this is qualitative data. So in quantitative data, we say the main things are experiment and surveys and observations, obviously, mechanical observations, and you can simulation. You can also simulate data. Sometimes very few or rare data are, we are having very less data, and say more and more observations are required to get the to apply the statistics statistical tools in a valid way. So a particular sample size is required. So sample size determination is very crucial part of the analysis, statistical analysis. So if you are having lesser data, then you on the basis of the parameters of these data, you have to generate the data through some distribution. So generally, if you are generating large and large population, then we use the normal distribution. Otherwise, you see which distribution your data is following, and you get the parameter of that distribution, and on the basis of these parameters, you generate the data, how much you wish. And here this is quantitative qualitative data, and we do collect the observations, collect the data for qualitative variable in these cases. It may be focused group, it may be individual depth interview, as the psychology people do, and focus group as the medical people do, and human observations, definitely, again, these two peoples do. And the case studies, this is done by almost all subjects. Now the collection of the data, this is the flow chart for the data collection, and this flow chart have been emphasized on the sources of secondary data. So here you can see the data source. The first one is primary, and we have discussed primary data sources, and this is chart for the secondary data case, collection points or collection centers, you can say, or sources say. So secondary data sources, you can see here internal records. In internal record, we know that sales or patronage results, marketing activity, cost information, distributor reports and feedback, and customer feedback. And here come to the external sources. You can see published data. Published data, electronic, maybe printed, and you can see it may be government, it may be trade association, periodicals, newspapers, books, annual reports, private studies, journals, even different websites as well. And you can see here the standardized source of marketing, maybe store audits, warehouse, withdrawal services, consumer purchase panels, single source data, and so many sources you can see. And the internet is one of the nowadays very important source of information for the secondary data. Now you can see here the primary source of data and secondary, as we have discussed in previous slide. Secondary data sources, document, maybe government publications, earlier research, census, personal records, client histories and service records, and many more which we have discussed in previous slide. Now primary sources of information, that is in sources of primary data, in terms of observation, maybe participant and non-participant, respondents and non-respondent persons. And through interview, maybe structured, maybe unstructured. Structured means you make the questions, already you have made the questions and you will ask, And unstructured, you are just going to the person and you are asking which is you are having in your mind. And then questionnaire, through questionnaire we can collect the information through self-administered questionnaire either by mailed questionnaires or by collective questionnaire. Collective questionnaire, now the questionnaire may be of two types, the questionnaire, and the another one is known as schedule. Schedule means in questionnaire we distribute the questionnaire to the people and they fill it, and in the schedule we ask the questions which are in questionnaire and we ourselves fill it. Now we come to the second part of the data collection, which is known as data representation or data presentation. So data presentation may be done in different ways, maybe in terms of tables, maybe in terms of different graphs. So presentation of data collection in the form of schedules and questionnaire. We have discussed the difference between schedule and questionnaire. Schedule is filled by the surveyor, while questionnaires are filled by the respondents. Are not self-explanatory. Nothing will be said by the questionnaires. You have to gather that, you have to prepare that information to make that data in terms of to make information through that data. So these are the form of raw data, obviously, whether schedule or questionnaire. In order to make them meaningful, these are to be made presentable. So if you are having some, raw material, then it is not saying anything. But if you are making it in some sense, something which is giving some information, then it is in the presentable form. So we have to present the raw data which you have collected through schedule or through questionnaire in some presentable form, so that we can get some inference from that data. So there are various ways of presenting that data. We will be discussing one by one. So presentation of categorical data, that is attributes which is collected in say Likert scale. So categorical data can be presented by two ways: either tabulating data, that is summary table, and the another one is graphing the data, that is bar chart, pie chart, Pareto diagram, and obviously more charts. So see here, summary table. What is summary table? The summary table is a visualization that summarizes statistical information about data in table form. That is tabulation of the data. That is one of the visualization is the tabulation of the data. So we make the table. That is example is current investment portfolio. So investment type, amount, and percentage. So there are four types of amount investment types: stocks, bonds, CD, and savings. You can see here amount in $1,000, 46.5, 32.0, 15.5, 16.0, and these are the percentage of overall. These are 100. So you can see here, this is going to be the percentage of that one. Okay, it is 110. So it is equal to say 100%. So it will be converted in this way. In percentage, we can easily convert it in different percentage. So it is sharing 42%, 29%, 14, and 14% for different investment type. Now we come to the another type of graph, that is graphical representation, and the first one is a bar chart. So bar charts are often used for qualitative data, categorical or nominal. Maybe categorical means here ordinal or nominal scale. Height of bar shows the frequency or percentage of each category. This height is showing the percentage or frequency of each category. Bar chart for the previous summary table, this one. See here, these are the amount and this is the percentage. So you can see here, this is summary for savings, CD, bonds and stock. So you can see here, this is going to be 46, and this is, I mean, 32, or how much, 32 and 15, 16. So it is 15 and 16. So this way you can see the frequency or the quantity is being presented by the height of that bar chart. Bar. Now the another one chart is the pie chart, very famous pie chart. Pie charts are often used for qualitative data, that is maybe ordinal and nominal. Size of pie slice, these slice 1, 2, 3, 4. So size of the slice shows the frequency or percentage of each category. Pie chart for the previous summary table is shown below. So you can see here, this is 42%, 15%, 14% and 29%. So you have, this is 360 degrees. So you have to make 42 in terms of degree. So you have 100 is equal to 100% is equal to 360 degree. So you have to convert each percent in different degrees. So and then you take the angle of that much degree, and you will get different slices of this pie chart. So you can see here maximum stakeholder, maximum investment is in stocks, and then in bonds, then in savings, and then in CDs. Now Pareto diagram. Pareto diagram used to plot a categorical data. It means it is also used for the categorical data. A bar chart where categories are shown in descending order of frequency. The difference between bar chart and Pareto chart is that here we represent different categories in descending order. A cumulative polygon is often shown in same graph. This cumulative, you just add everyone, and you can see here till 100. So a cumulative, I mean, graph is also shown here, polygon, to compare the different categories. Used to separate the vital few and from the vital many. So you can see here through graph and through this, I mean, Pareto, you can distinguish between the two. Now presentation of numerical data. This was presentation of categorical data. Now presentation of numerical data. So ordered array, that is stem and leaf graph, stem leaf, that is the tree diagram, stem leaf diagram, and frequency or cumulative distributions, and these includes histogram, frequency polygon, and ogive curve, obviously. Ordered array, a sequence of data in rank order. It means we will first represent the data in either in ascending order or in descending order, and then we will see the frequency. And the data may be represented in terms of tabular form. There are two ways to represent the data in terms of say group data and ungrouped data. If you are if you are dealing with the large data, then we make different intervals, and when you are making the interval, then this is known as I mean group data case. And if you are not making intervals, then this is the case of ungrouped data case. So a sequence of data in order, rank order, shows range minimum to maximum, provides some signals about variability within the range. You can have, that is why we calculate in descriptive statistics, we calculate mean, median, mode, and obviously standard deviation range, to have idea of dispersion and location. So provide some signal about variability within the range, may help identify outliers, definitely unusual observation, which is either it may be very high or may be very low. So if the data set is large, the ordered array is less useful. If data is very large, so it is very, I mean, confusing and very typical to make the calculations. So that is why there we apply the grouping of the data, and we make the class intervals. Example, data in raw form as collected 24, 26, 24, 21, 27, 27, 30, 41, 32, and 38. Now data in ordered array from smallest to largest. That is fit. We have arranged the data in ascending order. Then it is 21, 24, 24, 26, 27, 27, 30, 32, 38, 30, 41. So now you can count the frequencies. Numbers are 21, frequency is 1, 24 frequency is 2, 26 frequency is 1, 27 frequency is 2, and these are having frequency as 1 because these are single observations. Now we come to a stem and leaf diagram. So we have to separate the sorted data series in leading digits. Leading digits makes the stem, and the ones or tens positions digits make the leaves. So and the trailing digits makes the leaves. So if you are having these, say these numbers 21, 38, and 41, so 2, 3, and 4, these are the stems, these represent stem, and 1, 8, and 1, these are leaf. Now suppose you are having number 21, 22, 31, and 39, 38, and 35, say, then the stem will be 2, 3, 4, but leaves will be 1, comma, if it is 25, then 1, comma 5. If it is 35 and 38, so 5, comma 8. And so whichever the numbers are having in 20s, all will be represented here in ascending order in leaf. Now frequency or cumulative distribution or frequency distribution. What is a frequency distribution? We represent the different numbers along with their frequencies in table. So that will be the that is the frequency distribution. A frequency distribution is a list or a table containing class grouping if the group data case is there, or ungrouped data, maybe ungrouped data case. Ranges within which the data fall. This is known as class interval. The corresponding frequencies with which data fall within each grouping or category. The reason for using frequency distributions are, these are the reasons why we use this frequency distribution. It is a way to summarize numerical data. It condenses the raw data into a more useful form. It allows for a quick visual representation of the data in terms of table. Maybe if data is large, then we make group it, make different class intervals along with the frequency, or say just numbers along with their frequencies for ungrouped data case. Now class intervals and class boundaries. Each class grouping has the same width. Determine the width of each interval by width of the interval is equal to range, that is maximum minus minimum, divided by the number of desired class groupings. Suppose we wish to make the, say, 10 class, then we have to divide the range by 10. Usually at least 5 but not more than 15 groups are considered as good. Class boundaries never overlaps. Round up the interval width to get desirable endpoints. Okay. Now the class intervals are two types. One is known as exclusive class type of interval, and another one is inclusive class interval. Suppose we are having class intervals 0 to 9, 10 to 19, 20 to 29, 30 to 39, 40 to 49. Such type of class intervals are known as inclusive class interval because upper limits are included in that class interval. But if we are dealing with the exclusive type class interval, it means if the class intervals are of the type 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50. Here you can observe that the upper limit of one class is the lower limit of another class. So, but for applying the statistical tools, continuity is very important thing. So here this type of class intervals are known as exclusive type class interval because the upper limit is excluded from that class interval. So 10 will be excluded from first, 20 will be excluded from second class interval, and similarly 30, 40 and 50. Now we can make the inclusive class interval into exclusive class interval. If you are given inclusive class interval, but if you have to apply statistical tools, then you will have to make this into exclusive type class interval. So what you have to do, you have to do nothing, but you have to do, you just calculate the jump. Jump is nothing but it is the difference between the upper limit of previous class and lower limit of the next class. Suppose we are making the class intervals which we have discussed, that 0 to 9, 10 to 19, and 20 to 29, 30 to 39, 40 to 49, and we have to make it as exclusive type class interval. So what is the jump? The difference between lower limit of next class and upper limit of the previous class. So the difference is 10 minus 9, that is 1. So suppose it may be a number. So if it is h, then we have to divide by 2, that is h by 2. Here it is 1 by 2, that is half. So you add these numbers, that is h by 2 in upper limits, and add 2 upper limits and subtract 2 lower limits. So you can see here, if half is subtracted from lower limits and half is added to upper limits, so the class intervals will be minus 0.5 to 9.5, 9.5 to 19.5, 19.5 to 29.5, and so on. So you can see here we have made inclusive type class interval into exclusive type class interval, and now you can apply different formula for calculating mean, median, mode, and the other things. Now frequency distribution, this is example. Manufacturer of insulation randomly selects 20 winter days and records the daily high temperature. Okay, and the temperatures are these 20 temperatures for 20 winter days are 20, 24, 35, and so on. Now you have to make the frequency table, frequency distribution. So for frequency distribution, we need to follow the following steps, which we have discussed earlier as well. Sort data in ascending order. It means you have to arrange this in ascending order. Write the smallest one first, then second is smallest, third is smallest, and so on. So it is 12, 13, 17, 21, 24, 24, 26, 27, 27, 30, and so you can observe the repeated numbers as well. So find the range, that is maximum minus minimum. So it is 58 minus 12, that is 46. Now how many interval you wish to make? So select number of classes, that is say 5, usually between 5 to 15. Not less than 15, not more than 15. Not less than 5 and not more than 15. It's considered to be good. So compute class interval, that is width. So it is 46 divided by 10. 5. That is almost 10 in round figure, 9 point something. So determine class boundaries, that is limits. You can apply the difference. So it is 10, 20, 30, 40, 50, 60. So you can this way you can make the classes. Now compute class midpoints. So you can here calculate midpoints. That is 10 plus 20 divided by 2, 20 plus 30 divided by 2, and so on. So this is 15, 25, 35, 45, and 55. Count observations and assign the classes. So you make the interval and you see the frequency. How many numbers are coming in that? except the boundary upper limits of the class. So you can see here 10 but less than 20. So it is 10 to 20 means 10, 10 to 20, 29, sorry, 19, not 20, but less than 20, less than 30, less than 40, less than 50, less than 60. So you can see here frequency. So how many less than 20? So you can count here 1, 2, 3, only 3. So you can see here 3, then 6, 5, 4, 2. So it is 20. 20 observations are there. Now you can represent them in terms of percentage. So 3 of 20, that is 15%, 6 of 20, 30%, 5 of 20, 25%, and so on. And now you can represent the in terms of cumulative frequency as well. So it is 3, then 3 plus 6, that is 9, then 9 plus 5, that is 14, 14 plus 4, that is 18, and 18 plus 2, that is 20. Now you can also represent it in terms of percentage. So you can cumulative, that is 100%. So you can see here 15 and 45% and 70%, 90% and 100%. You can see. Now histogram. So there is difference in bar diagram and histogram. Histogram is always made for the group data case, that is with, the frequency with the class intervals. So a graph of the data in a frequency distribution is called a histogram. The class boundaries or class midpoints are shown on the horizontal axis. That is, these are the class intervals, and here frequency, and you can see the height is the frequency of that class interval. And if okay, first see, then we'll discuss later. The vertical axis is either frequency, relative frequency, or percentage. Bars of the appropriate heights are used to represent the number of observations, that is frequency, within each class, that is class frequency. Example, for previous data, the histogram should be like this. There will be no gap between bars. See here. And if you are taking the midpoints of these bars and adding these from end points, so this will be the frequency, and you add these midpoints through the scale, then it is known as frequency polygon. And if you are adding the midpoints of each bar through freehand, then this is known as frequency curve. See here, this is frequency polygon. In a percentage polygon, the vertical axis would be defined to show the percentage of observations per class. Example, but we have to add the midpoints along with the endpoints by the scale, so it makes the frequency polygon. And frequency curve, if you are adding these points through freehand, so freehand curve will represent the frequency curve. Now ogive curve is nothing but it is cumulative frequency curve, and it is of two types, less than type and more than type. So this is less than type. This is less than type cumulative frequency curve, and more than type will be this type, upper to lower. And the point where less than type and more than type ogive curves cut each other is the median of that distribution. We draw a perpendicular line, and the point touching this scale is the median of the distribution. Now these are guidelines for good data representation, that is not distorting the data, avoiding unnecessary adornments, no chart junk, using a scale for each axis on the 2-dimension graph, not on higher dimension graphs. The vertical axis scale should begin to at 0. Definitely it should start with the 0. Properly leveling of all axes, where is x-axis, where is y-axis. The graph should contain a title, using the simplest graph for a given set of data. So you should choose a very simple graph so that a layman can understand the things. the information which you wish to show through graph. Now we come to the data, whether data is going to be reliable or valid, or the data categorical, I mean this quantitative data is representing normality or not. So these are some points, extra points I thought that we should discuss. So this is a reliability, where your data is going to be reliable or not. So there is option in SPSS, you can check the reliability of the data. And the measure is Cronbach alpha. You can see the internal consistency. If the consistency is there, then you can rely. So reliability depends on the internal consistency. And if the value of the Cronbach alpha comes out to be less than or equal to zero 0.9 or higher, say, then it is excellent. It means your data is reliable. And if it is lying between 0.8 and 0.9, then it is good. And if the value of Cronbach alpha for your data lie between 0.7 and 0.8, then it is acceptable. And if it is less than 0.7, it means it is lying between 0.6 and 0.7, then it is questionable. And if it is lying between 0.5 and 0.6, then it is poor. And if it is less than 0.5, it is unacceptable. It means it is not reliable at all. So these are some some terminology regarding validity, reliability, and accuracy of the data. And we will be, discussing this and through graph. And you will be provided this for primary data as well as for secondary data, but you can have an idea from this graph what is reliability and what is validity. You can see here this is reliable but not valid. Means if say some persons are saying that this particular thing is say it is not mobile, but the people are saying that it is mobile. Every people is saying that it is mobile, then someone will rely that it is mobile, because all the internal consistency is very high. So we can rely on that it is mobile. But actually it is not mobile, so it is not valid. So here you can say here all observations are very close to each other, so we can rely, but it is not valid because valid point is here. You can see here low validity and low reliability, because points are scattered and these are far from this reality. And you can see here neither these are far from the reliability, and as well as they are dispersed in either side of the reality, not dispersed around that reality, the real point. So it is not reliable and not a valid point. Not valid, not valid, not reliable. And you can see here it is valid as well as reliable. Now you can check the normality of the data for the case of quantitative data through box plot. You can see here if whiskers are of same length and median is lying at the midpoint of the interval, this box, then you can see your data is normal. And the points outside these whiskers are known as outliers and extreme values. So this is representing Q1 and this is representing Q3, and this is median is Q2 quartiles. So the first quartile and third quartile, it means this box is representing 50% of the data, and 25% is this, 25% is 50% is this, and 50% is this. So Q3 minus Q1 is the range of the data. If the range, this any point lie 1.5 times of this range, then this is known as outlier. And if it is lying say more than 3 times, then it is extreme value point. So you can see here the top box of the box is upper fourth of the or 75th percentile. This is 70. It means till here it is 75%, 25%, 25%, 25%, and rest 25%. The bottom of the box is the lower fourth, that is 25 percentile. 50% of the score falls within the box or interquartile range. That is Q3 minus Q1. and the horizontal line is the median, that is, this is the median. And the ends of the whiskers represent the largest and smallest value of the that are not outliers. Actually this is lowest one and this is highest one, the smallest and largest one. And outlier O, this one, is defined as the value that is smaller or larger than 1.5 times box length, that is 1.5 times the interquartile range, that is quartile deviation, sometimes we call it as quartile deviation. And the extreme value, that is E, is defined as the value that is smaller or larger than 3 times the interquartile range or quartile deviation. Normally distributed score typically have whiskers that are about the same length, and the box is typically smaller than the whiskers. It means that this length is more than this box length, and the median lie in the midpoint of the box for the normally distributed data. You can check this normality in SPSS by clicking on analyze, then descriptive statistics, then explore, and you can get the outliers. You can have the graph as well. So these you can see here normality and negatively skewed, positively skewed. So you can this way you can calculate the skewness as well as kurtosis of the data. So you can test the normality this way, and you can see here these are two tests. Through test you can, so we should rely on the we should more rely on the test rather than the graph. There are two tests for normality, that is Kolmogorov-Smirnov test and Shapirovic test, and through both the tests for the considered data you can see here the p value is 0.2 and here 0.08. It means both the values are more than 0.05, so the data is normal. We can conclude that the data is normal. And if this QQ plot is representing all the points are lying this near to close to this line and making a very sharp S, then the data is normal. Otherwise outliers will be there and extreme values or some pattern will be there for non-normal data. So these are different tests we apply in case of parametric or non-parametric, categorical or normal or non-normal data. So you can enjoy these tests. These are some references which from where that this information has been collected. So this was all about today's discussion. If you have any question, any query in your mind, please ask. I will be happy to answer the questions. Dr. Yadav, I think it is over. Hello. So if you have any question, anyone, you just unmute yourself and ask the questions.
The participants, if you have any query regarding to these presentations,
yes,
you may
very nice
unmute
presentation,
themselves
sir.
and
Sir,
ask.
very nice presentation.
Thank you.
I like sir. It is very good, very good. बहुत ही सारे कंसेप्ट क्लियर हो गए सर, बहुत ही सारे कंसेप्ट. थैंक यू सर, बहुत बहुत शुक्रिया.
But if you have any person, any question, any doubt, then please ask. So
there are some questions in the chat box, sir.
okay.
So yes, you may open the chat box, sir, and
Okay. What is open-ended question? Open-ended questions means if just I ask you what you like to become in your life, so everyone say that I become to this one, this one, this one, what, whether it is, I mean, close to reality or not. So that is open-ended questions. That is, matlab, it means the person will may answer hypothetical answer. Sir, what about geometric data? Genomic data may be genomic data, maybe it will depend on the surveyor or say experimenter. If it is represented in terms of quantity, then it will be quantitative data. Otherwise, we will categorize it in different categories. And if you are giving some ranks, then it will be ordinal, otherwise nominal. Okay. Box plot and outlier. So box plot, just we have discussed box plot. See here, this is box plot. It is representing red portion, 50% of the data, 25% is this one, 25% is this one. We have discussed that if this is quartile range, this is known as quartile range Q3 minus Q1. So if any point is 1.5 times the quartile range, then it is known as outlier. And if it is 3 times that deviation, quartile deviation, then it is known as extreme value. So you can see here, if the both the whiskers are of same length and the median is lying between this box, and generally whiskers are larger than the height of this box, then the data is normal, otherwise it is going to be non-normal. So
सर मैं ये क्वेश्चन पूछना चाहता हूँ, ये जो अनोवा टेस्ट है इसका क्या एप्लीकेशन होता है? अनोवा अनोवा टेस्ट
जो हम लोग कुछ टेस्ट जो है, जो सैम्पलिंग डिस्ट्रीब्यूशन कहलाते हैं, TF और काई स्क्वायर डिस्ट्रीब्यूशन होता है। तो अगर हम कोई दो ग्रुप का मीन चेक करना चाह रहे हैं, मतलब कि क्या एवरेज किन्हीं दो ग्रुप का बराबर है कि नहीं, जो भी कैरेक्टरिस्टिक्स हो सकती है, आप कह लीजिए कि दो क्लास के हम एवरेज मार्क्स चेक करना चाह रहे हैं कि बराबर है कि नहीं। तो अगर दो से ज्यादा ग्रुप का चेक करते हैं तो वहां एनोवा अप्लाई करते हैं, क्योंकि टी टेस्ट वहां पर नहीं अप्लाई हो पाता, क्योंकि वो इट इज कैपेबल ओनली फॉर द टेस्टिंग ऑफ टू ग्रुप्स मीन्स ओनली। तो ऐसी जगह पे हम लोग एनोवा का इस्तेमाल करते हैं।
बोले तो टी के आगे जाकर अनोवा अप्लाइड होता है, जब ग्रुप ज्यादा हो गए तो अनोवा टेस्ट यूज
एनोवा अप्लाई करेंगे जी।
ओके सर, थैंक यू सर।
और किसी की कोई समस्या हो, इफ यू हैव एनी प्रॉब्लम प्लीज आस्क, because this is running, so I am only capable to capture some of the questions. Not audible. I think my mic is open.
Audible, sir. Yeah, so actually, your voice is very clear, sir. I think the problem that side.
Maybe.
But, I'm hearing a proper your voice, sir.
What audible?
Dr. Shumitra, I think she asked us.
What is minimum number of data points for identifying outliers? No, I don't think minimum numbers, at least 6. 6 or lesser. If you are having observations 6 or lesser, then we have to apply non-parametric test. So 6 may be considered as the minimum number. More than 6. If anyone is having any more question, otherwise I will say to Dr. Singh that we should wind up, I think.
Dear participants, it is an open session for you. And you
Definitely,
may
you can open your mic and you can ask.
ask, you can unmute themselves and you can ask any questions regarding to these presentations.
Hello, sir.
Yeah.
Yeah, it's not related to data, but I just clarify something. What is the difference between multiple regression and stepwise regression for the data analysis?
Multiple regression and stepwise regression is one of the method for multiple regression, and multiple regression is the case where we consider I mean more than one explanatory variable, independent variable. Otherwise it is simple. So there are so many methods for calculating the, I mean for the estimation of the parameters of that model. So stepwise regression is one of them.
Thank you, sir.
हाँ सर, मुझे ये अभी मुझे और एक क्वेश्चन पूछना है। पैरामेट्रिक टेस्ट और नॉन पैरामेट्रिक टेस्ट, इसमें कैसे हम क्लासिफिकेशन करेंगे? इनको हम पैरामेट्रिक टेस्ट कहेंगे, इनको हम नॉन पैरामेट्रिक टेस्ट कहेंगे।
जब हम नॉर्मलिटी चेक करते हैं, अगर डेटा नॉर्मल डिस्ट्रीब्यूशन से आ रहा है, इसीलिए अब ये नॉर्मलिटी टेस्टिंग का हमने बताया है, जो सैपेरोविल टेस्ट और स्मोग्रोव कॉल्मोग्रोव स्मोग्रोव टेस्ट दो लगते हैं। अगर डेटा नॉर्मल है तो हम लोग पैरामेट्रिक टेस्ट लगाएंगे, अगर डेटा नॉन नॉर्मल है तो हम लोग नॉन पैरामेट्रिक टेस्ट लगाएंगे।
टी टेस्ट, एफ टेस्ट, वन वे टेस्ट, डबल वे टेस्ट, ये क्या होता है सर?
ये सब पैरामेट्रिक हैं।
अच्छा जी, बिल्कुल बिल्कुल बिल्कुल, थैंक यू।
Hello, sir.
Yeah, हाँ बताइए।
Suppose we are there is one data set which is interval of quantitative, one is ratio. Does it give any indication that that how to present these data? Is there any set of criteria to present interval data set or ratio data set? Or we can present any by frequency or any by histogram?
Yeah, all may be presented by the same fashion. Okay. But the difference is that if 0 is having absolute meaning, then it is scale. Okay. Otherwise, we cannot write zero temperature means zero temperature. IQ 0 means the person is brainless. So we cannot say this type of.
But it does not affect the way of presentation. Yeah, it does not affect the way of presentation.
No. You have to mention that one.
Okay. Okay, sir. Thank you.
Participants can also ask their queries in the chat box. Yep. Okay, so there is a query from Sumit Ghosh. For any medical thesis, what is the minimum number of cases that is essential?
Actually, it will depend on the population you are covering. So sample size determination is mandatory there.
Okay, so
it cannot be generalized. Actually, it cannot be generalized. So I mean, how much population you are going to, I mean, cover. So it will depend, the sample will depend on that one. And there are certain formulas to calculate the sample size, required sample size.
Okay, sir. Okay, sir. So, so I think there are no more questions from the participants.
I
So,
think
Dr. Singh, can we wind up?
Yes, yes, yes. I think the lecture was very nice, and all the participants has understands
Yeah,
very.
yeah.
So there is no question from audience, and I called to many times, but there are few questions from the audience side, and sir replied very quickly.
So,
So
yeah.
thank you, sir, for
So if they
coming
have, yeah. So if
in
they
this
have any query in the
platform.
future, they can write in the by email, or so we will forward
Yes,
to
yes,
sir.
yes, yes, yes. If you are have any doubt, you can email to Dr. Yadav sir, or on our official email sciencetech487@gmail.com, and I will forward to Dr. S.K. Yadav sir, and he will reply to you. So thank you, sir. Thank you, Dr. S.K. Yadav sir, for coming in this platform and delivering this very wonderful presentation. So Dr. Yadav sir.
So thank you so much, sir, for your valuable session, and I hope all the participants have enjoyed today's session. So thank you once again to all the participants. Thanks to our esteemed resource person. We will meet tomorrow.
definitely.
So
Thank you.
thank you so much. Thanks to all of you.
Bye. Good night to all of you. Thank you. Bye bye.